Hi, Assalamualaikum and good morning everyone. My name is Siti Khadijah, Binti Yasir Arpat, and my metric number is 306073. So today I'm going to present about my question, which is find the interval where the fx is equal to 2x powered by 3 plus 3x powered by 2 and deduct by 36x plus 4 is increasing and the interval where is decreasing. So for the first step, we need to find the first derivative. There are 4 terms, which is 2x powered by 3 and the second term is 3x powered by 2 and the third term is negative 36x and the fourth term is 4. So we get that the derivative for it is f prime x is equal to 6x powered by 2 plus 6x deduct 36. So the second step is find the critical point. So to find the critical point, we need to solving the f prime x is equal to 0. So we get that 6 powered by 2 plus 6x deduct 36 is equal to 0. So we divide the entire equation by 6 to simplify it. So x powered by 2 plus x deduct 6 is equal to 0. Now we need to factor the quadratic equation and we get that x negative 2 and x plus 3 and then is equal to 0. So this critical point is x equal to 2 and x equal to negative 3. So for the third step is testing the sign in each interval. By the critical point, we get that there are 3 intervals, which is negative infinity and negative 3, and the second one is negative 3 and 2, and the third one is 2 and infinity. So to determine whether the function is increasing or decreasing on this interval, we need to test the sign of f prime x in each interval by picking a test point. So for the first interval, which is negative infinity and negative 3, my test point is negative 4, so it means that x equal to negative 4. So we get the value of f prime x is 36, which is the value is positive. So it means that the function is increasing. For the second interval, which is negative 3 and 2, my test point is 0. So it means that x equal to 0. So f prime x is equal to negative 36. So it means that the value is negative, so it means the function is decreasing. So for the third interval, which is 2 and infinity, my test point is 4, so it means x equal to 4 and f prime x is equal to 84 and the value is positive, so it means the function is increasing. So for the conclusion, the function of fx increasing on 2 interval, which is negative infinity and negative 3 and then 2 and infinity. As for the function fx decreasing on interval negative 3 and 2. So that's all.
Hi everyone, my name is Goh Qian Ming 306090. I will present about the question B. For this question, it has been given that the demand equation for a monopolist product is P equal to 200 minus 0.98Q and also the cost function CQ. To find the marginal profit MP function, we can start by calculating the profit function, which is profit equal to revenue minus cost, and the equation is PQ equal to RQ minus CQ. The revenue function is RQ equal to Q multiplied by the demand equation. After substitution and simplification, we can get the profit function equal to 198Q minus Q squared minus 8,000. So we can make the differentiation to the profit function and get the final answer, which is MP equal to 198 minus 2Q. Next, we want to find the interval where the MP is falling and rising. We already get the MP function before this, which is 198 minus 2Q. So we want to make differentiation for the MP function and get the answer, which is negative 2. The negative 2 is less than 0. Therefore, the interval MP is falling. The last question is, we want to determine the average profit AP function. The equation for AP function is equal to profit function divided by Q. After substitute the profit function and simplify it, we can get the final answer, which is AP equal to 198 minus Q minus 8,000 divided by Q. This is all part for me. Thank you.
My name is Xuan. My metric number is 306088. I will present about question C. A manufacturer found that the total cost of producing S unit of product is given by CS equal to 0.02 S squared plus 2S plus 8,000. At what level of production will average cost be a minimum? First, we use the formula that SCS equal to CS divided X, which is 0/02 x squared plus 2s plus 8000 divided by x. Then we simplify it, which is SCS equal to 0/02s plus 2 plus 8000 divided by x. Next, we find the derivative of SCS. dAc per ds equal to 0/02 minus 8000 divided by s squared. We set the dAc per ds equal to 0. Then 0/02 equal to 8000 divided s squared equal to 8000 divided 0/02, then get 14,000. Then s equal to 632.46. S equal to 632, the average cost is minimized.
My name is Ee Ling. My metric number is 306062. Based on the question D, what is the price elasticity of demand when quantity is 10 if a firm's demand function is Q equal to 60 minus 2p power of 0.5, where p power of 0.5 is greater than equal 0, Q is less than equal 60. The price elasticity of demand refers to an economic measure that indicates how much the quantity demanded of a product changes in response to a change in its price, essentially showing how sensitive consumers are to price fluctuations. The formula is ED equal to DQ over DP times P over Q. The first step is find the price. The demand function is given by Q equal to 60 minus 2p power of 0.5. Next, we need to substitute Q equal to 10, which is based on the questions. So we will get 10 equal to 60 minus 2p power of 0.5. After that, we need to rearrange the questions, which is 2p power of 0.5 equal to 60 minus 10. So we will get 2p power of 0.5 equal to 50. After that, we need to divide both sides by 2. So we will get the answer, which is p power of 0.5 equal to 25. After that, we need to square both sides, which we will get the answers, which is p equal to 625. The step 2 is calculate the derivative of q with respect to p. Next, we need to find the derivative, which is dq over dp. From the demand functions given, which is q equal to 60 minus 2p power of 0.5, we need to take the derivative with respect to p, which is dq over dp equal to negative p power of negative 0.5. So how to find the negative p power of negative 0.5? We need to use the negative 2 times 1 over 2 times p power of negative 0.5. So we will get the answers, which is dq over dp equal to negative p power of negative 0.5. The step 3 is evaluate the derivative at p equal to 625. So now we will substitute p equal to 625, which is dq over dp equal to negative 625 power of negative 0.5 equal to negative 1 over 25. So the last step is calculate price elasticity of demand. The formula for price elasticity of demand is ED equal to DQ over DP times P over Q. So we need to substitute the values. The first is DQ over DP equal to negative 1 over 25. The second is P equal to 625. The last is quantity equal to 10. So we will get ED equal to negative 1 over 25 times 625 over 10 based on the formula. So so after that we need to calculate ED equal to negative 625 over 250. So the final answer is negative 2.5. Conclusion: the price elasticity of demand when the quantity is 10 for the demand functions Q equal to 60 minus 2p 0.5 is negative 2.5. It indicating that the demand is elasticity at this point. This means that 1% increase in price will lead to a 2.5% decrease in quantity demanded.